Hey guys, I got this idea from my friend Casey, who does this for her tutors, and it works really, really well. So I'm going to we'll try it and see how you guys like it. And then we can kind of assess after the first 6 weeks and see if you want to do it differently. But I'm going to video a separate video for each week's science experiment or experiments, and then each week's fine arts assignment. And then you guys can at least see the supplies that I have for you. And then we can talk about it and you guys can ask questions, or we can brainstorm to do something a little bit differently if we want to. So I'm going to start with science. This is week 1 science. Just as a heads up, each one of you is going to have 8 of these in your tutor tubs, one for each one of your kids. So that's kind of fun. They can use it to draw pictures or take notes on what they're learning or what they see. Something really important this year that I want to make sure that we are constantly asking our kids during these science experiments is, what do you observe? The attending is what's really, really what really should be our focus during these science experiments. So constantly be asking the kiddos in your class, what do you see? What do you hear? And redirect them to say, what else do you see? Because there's always more that we can observe. So in your science journals, on the front cover is the scientific method. Especially the younger kids, you're not going to go through this every single week, and you probably won't with the older kids either, but it may make sense to kind of go through and pick out 1 or 2 and highlight them, just so that they begin to get an understanding of the scientific method and how it plays out as we go through these experiments. So that's just kind of an introduction. This year I bought kits for our science experiments, and they came basically with everything that we need for the whole entire year for science. So I might have some supplemental things that are in there, but everything should be labeled. And what we're going to do is we're going to have 2 tables set up in the room. And I know you guys aren't familiar with the church yet, but in the room where we will eat lunch, I will have 2 tables set up, and there will be 2 classes that are doing science simultaneously. So there will kind of be 2 stations, but your class will go through it individually with just your class, and we'll just need to make sure that we get through it in that 30 minutes so that the next class can come through and get it as well. But on each table will be either a box or a bag labeled with the supplies that you need for that week's experiments. So week 1 is in the Van Cleves awesome, magical, bizarre, and incredible science experiments. We're on page 2, which is experiment number 2, which is shaded. And we're doing 2 experiments this week. So there is 2 different things that we're going to accomplish, and both of these are outside. So we're going to be praying for good weather that first community day. The first one is shaded, and it says to demonstrate how a planet's surface temperature can vary. So what you're going to need on your tables will be a box that looks like this, and it says week 1, and it has the science experiment numbers in the book, so you don't even have to know before you get there. But what is in this first box are some thermometers. And for the younger kids, this might help kind of take up a little bit of time too, but you might want to just ask, does everybody know how to read a thermometer? I know that we just learned how to do this in math with Isabella, who is going into 4th grade. So some of the younger kids especially may not know how to read a thermometer. And it's also a good math incorporation because you have to count by tens. So that might be something that you can do when you first get started with this experiment. But the point is to put 1 thermometer on the ground in the shade, and then 1 thermometer on the ground in the sun. And you want to put it kind of on the same, like if you put 1 in grass, put the other one in grass. Don't put 1 on the concrete and 1 in the grass. But 1 in the shade and 1 in the sun. And then you're supposed to let it sit for 20 minutes, which is most of our science time. I don't think we're going to do 20 minutes, but what I would recommend is that you set this up first. Set the thermometers out, 1 in the shade, 1 in the sun, and then move to the second experiment. And when you finish the second experiment, then you can come back and finish this one. So that's what I'm going to do. maybe go through how to read a thermometer. I will have extra thermometers in these boxes so that if your kids want to pair up and practice reading a thermometer, they can do that. And then set them one in the shade and one in the sun. Then moving on, the next experiment for week 1 is actually on page 11, page 10, which is number 17, and it's called Same Place. And the purpose of this one is to determine why satellites appear to be stationary, even though we know they are moving. So the materials that you need for this one, also in this box, is a rope. And this says about 3 yards long. Ours says that it's 10 feet, so that works totally fine. And what you're supposed to do is you're supposed to get around a tree or a pole. There's basketball poles that are out there too. I'm trying to think what else is big that we could use, but just find something that you can stand next to. And then one person is going to stand with their back to the pole or tree or whatever and hold one end of the rope. And then you're going to have another helper holding the other end of the rope. And the person that has the other end of the rope way far away, 10 feet away, is going to start moving in a circle. And the person in the middle has to move at a pace to keep up with the person outside. And the concept that we want them to kind of get from this is that the person on the outside circle has to move faster, but they are staying in line with the person that is moving on the inside circle. So the concept is that the distance around the outside of the circle is much bigger than the distance around the inside of the circle, which means the person on the outside has to walk a whole lot faster than the person on the inside. And so some application, like how does that tie into what we're doing in science? The satellites that are orbiting the Earth have to move very, very fast, but it doesn't appear that they're moving at all. And then some questions, some adjustments that maybe we could do might be, what if the rope was shorter? What if the rope was longer? How would that change the satellite person, the person on the outside? How would that change how quickly or slowly they might have to move with respect to the person that is standing still? So again, what do you observe? Asking your kids, what do you see? What do you think? What do you think would happen if the rope were longer or shorter? What do you think would happen if the person in the center moves faster or slower, if the person on the outside moves faster or slower? Those are things that we can kind of do to get them to start asking themselves questions and really begin to try to take a little bit more ownership of what it is that they're learning in science. So once you've kind of done that experiment and you've talked through that, then you can go back to the thermometers. And you'll read and record the 2 different temperatures that you see, and then we'll ask, why does the temperature in the shade vary from the temperature in the sun? And the book's explanation says that the tree or large structure blocks some of the light rays, providing a shaded area on the ground. This protected surface area is cooler due to the decrease in light energy received. The same type of surface in direct sunlight receives more light energy and becomes hotter. In the same way, the temperature of planet surfaces can vary depending on whether the landscape has large structures to provide shade. So younger kids, a good application would be, what kinds of surfaces would have hotter or cooler temperatures? And of course, they'll think of places with lots of trees would be cooler than places with no trees, like maybe a desert. You'll get some kids, I'm sure, that will have picked up on weather things. Well, if you live by the ocean, you'll get a cooler breeze. Those kinds of things also impact surface temperature. So don't shy away from letting them explore those things. Another application that would be good, maybe even for the older kids, is if we're looking at a planet, how would we be able to determine where might be a better place to land on that planet if we were going to explore it? What are things that we might be able to look for to help us determine what the temperature might be before we get there? Those kinds of things would be good questions to ask. And again, we're observing. If they want to take the extra thermometers that we have and do more than one test, so set one thermometer on the grass in the shade, one thermometer on the grass under a tree, one thermometer in the shade on a sidewalk and do those kinds of things. I say definitely whatever you think you have time for, and let them just really explore the variations in surface temperature, because that's kind of the goal of this particular experiment. And that's it for Science Week 1.